Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a straight line is going on and we are successfully finished the 9 lectures. Okay, so in a previous lecture that we are discussed about when the two objects are there, so one of them is projected vertically upward direction at the same instant of time another object is freely falling towards the ground from certain height h. So what is the time taken by the two objects to meet each other? So t is equals to h by u. So at what time the velocities of the two objects are becomes the same and we are find the displacement of the two objects from the ground where they are meet or the displacements of the two objects where they are meet from the height of the tower h. Okay, and also we are discussing some numerical problems on the concept. Okay, right. So in this session that we are going to discuss about when the object is projected from the tower of height h. So what is the height of the tower? What is the time taken by the object to reach the ground? The applications based on this concept, that means balloon problems. Okay, so whenever the balloon and the stone are traveling in a upward direction, the balloon has an initial velocity u and it is releases the stone at a height h. So what is the time taken by the stone to reach the ground? What is the height of the balloon from the ground? Okay, what is the height of the balloon after the stone reaches to the ground? And what is the displacement between the two objects, that is balloon and the stone, after the time t? So all these things that we are going to discuss in today's lecture. Okay, so my name is Rakesh Kanganti. Welcome to our beautiful physics channel, RakeshSir Physics. Right, shall we start the session? Okay, what is the chapter going on? Motion in a straight line. Motion in a straight line. And what is the class number? This is the class number 10. Okay, right. So what is the concept today? Vertical projection of an object from a tower. Okay, so what we have to find? We have to find expression for the height of the tower. Height of the tower. Okay, are you getting? Right. So this is our concept. Right. So I'm taking one tower. Let us consider this is a ground. Okay. So on this ground there is a tower. There is a tower. Let us consider the height of the tower is capital H. The height of the tower is how much? Capital H. From the top of this tower, I'm just projecting an object in a vertically upward direction. So already I told you that if you want to project an object in a vertically upward direction, what you have to give? We have to give some initial velocity for that object. Okay. So whenever the object is moving away from the ground, its acceleration due to gravity is equals to how much? Minus g. Okay. Now we are projected an object from the top of the tower, and this object is moving like this. La 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 la. Okay. So after reach to the maximum height, again the object is moves towards the ground, and again the object is moves towards the ground like this. Okay, so just draw this diagram like this. Okay, so this is the diagram, right? So I'm just considering the displacement of the object from the point of projection to maximum height, let us say x. This is what displacement of the object in a upward direction. Okay, so I'm just drawing the line from the top of the tower like this. If this displacement is x, then this displacement is also x. Okay, so after this, the distance traveled by the object or the displacement of the object is equals to how much? H. H be the displacement of the object. Are you getting? If this is x, have a look, these two lengths are same. If this is x, then this is also x. So after x, so the distance traveled by the object is equals to how much? Which is equals to height of the tower. Okay, so in a displacement concept, I told you that whenever the object is moving in an upward direction, this is what plus y. This is what? Minus y. This is what? Positive x direction, negative x direction. Here the object is moving in an upward direction. Then the displacement of the object is what? Positive. Displacement of the object is how much? Plus x. Here, after reaching to the maximum height, the displacement of the object is towards the ground. The displacement of the object is towards the ground. Have a look. Towards the ground along negative y-axis. Then this displacement is how much? Minus x. Are you getting? It is moving towards the ground. It is a displacement. Displacement is a vector quantity. Then we have to add its sign. Again from here to here. Again the object is moving towards the ground and its displacement is how much? Minus h. That means here negative sign shows simply decrement. Simply a decrement in the displacement. H means what? Minus h means what? The displacement is decreases. Minus h means what? The height of the tower is decreases. Height of the tower is decreases. That's it. Okay. Right. I want to find the total displacement. So total displacement of the object. Let us say s is equals to, this is what? Plus x. After that minus x. Then after that minus h. So plus x minus x get cancelled out and we got the displacement of the object s is equals to capital H. So this is what? The displacement of the object. Okay. Now expression for height of the tower. Height of the tower. So we have the third equation of motion. What is that? S is equals to ut plus half at square. S is equals to ut plus half at square. Okay. So what is the displacement we got? Minus h. This is equals to, what is the initial velocity of the object? U. Let us consider the total time taken by the object to reach the ground. Let us say t. T be the total time taken by the object to reach the ground from certain height h of the tower. Okay. So t, have a look. A is equals to how much? Here a is equals to minus g. Plus into minus half g t square. So minus h is equals to ut minus half gt square. Just send this negative to that side. So it becomes h is equals to, if minus went to that side, so what happened? Plus ut becomes minus ut, minus half gt square becomes plus half gt square. Therefore, half gt square minus ut. Okay. So this is the expression for the height of the tower. How much? H is equals to half gt square minus ut. So this is the expression for height of the tower. Are you getting any doubts? Okay. Have a look. Right. So what is the height of the tower we got? H is equals to half gt square minus ut. H is equals to half gt square minus ut. Okay. So to find the time taken by object, time taken by an object to reach ground, compare above equation with a quadratic equation. So what is quadratic equation? Ax square plus bx plus c is equals to 0. Already I told you that. Just compare this equation with quadratic equation. So have a look. Here we have a half gt square minus ut. If plus h went to that side, it becomes minus h. This is equals to 0. At the place of x, we have t. Okay. So what is the value of a? Compare these two equations. A is equals to how much? Ax square. Okay. Half gt square. Then what is the value of a? A is equals to half g. And b is equals to what? Bx. Ut. At the place of x, we have t. At the place of b, we have minus u. And c is equals to how much? Minus h. C is equals to how much? Minus h. Now what we have to find? we have to find the time taken by the object to reach the ground. As we know, to find the roots in case of quadratic equation. So what is that equation? X is equals to minus b plus or minus under root of b square minus 4ac divided by 2a. Minus b plus or minus under root of b square minus 4ac by 2a. Okay, right. So at the place of x, we have what? T. So t is equals to minus of, what is the value of b? Minus u plus or minus under root of, what is b square? Minus u square minus 4. What is the value of a? A is equals to half into g into c. What is the value of c? Minus h divided by 2 into a. What is the value of a? 1 by 2 into g. 1 by 2 into g. So t is equals to minus into minus plus u plus or minus under root of minus u whole square. It becomes u square minus into minus plus 2 ones are 2 twos are 4 2gh. Are you getting? Divided by 2 to get cancel out and we got t. So by using this equation, t is equals to u plus or minus under root of u square plus 2gh by g. So by using this equation, we can find out the time taken by the object to reach the ground. Are you getting? Any difficulties there? Okay, very good. So based on this concept, we have one application. So application number 1. Application number 1. So this application is also called as a balloon and a stone problems. Balloon and a stone problems. Okay. So how to solve the balloon and stone problems? Have a look. Let us consider this is a ground. Okay, this is what? This is a ground. So from this ground, a balloon is moving in an upward direction. A balloon is moving in an upward direction. Okay, right? So the velocity of the balloon, let us say u. U be the velocity of the balloon, and it is at a height of h from the ground. Okay, right. So this balloon consisting of a stone. This balloon contains a stone. Okay, so stone and a balloon both are traveling in an upward direction at a particular height h from the ground. Right, have a look. At a particular height h from the ground, the balloon the balloon excuse me the balloon releases the stone. The balloon releases the stone. Okay, so the balloon and the stone together moving in an upward direction. Okay, at a particular height h, from the ground, the balloon, what happened? Releases the stone. What is the velocity of the balloon? U, and it releases the stone, at a height h from the ground. Have a look what happened at this condition. Now this diagram becomes like this. Have a look. This is the ground. Okay, and the balloon is at a height h from the ground. Okay, and it is moving with a velocity u. U be the velocity of the balloon, and it releases the stone. The balloon is moving like this, and it releases the stone. So what is the velocity of the balloon? U, and it releases the stone. Those two are moving together. Now what is the velocity of the stone? What is the velocity of the stone? U. So with velocity u, initial velocity u, this is not an initial velocity of the balloon. It is moving with velocity u. Okay, and after reaching to the certain height h from the ground, it releases the stone. Now what is the initial velocity of the stone? So whatever the balloon having the velocity, that velocity becomes what? Initial velocity for the stone. Are you getting? Right. So with this much of initial velocity, the stone is moving upward direction, and after reaching to the maximum height, again it reaches to the ground. Okay, have a look. Just compare these two situations. So what is the height of the balloon? H from the ground. What is the height of the tower? H. From this height h, the object is projected in vertically upward direction. From this height h, the object is projected vertically upward direction. Have a look. Like this. Like this. Okay. Now these two are what? Same situations. Now, what is the height of the balloon? What is the height of the balloon from the ground when it releases the stone? When it releases the stone. Have a look. What is the height of the tower when it releases the stone? How much? H is equals to half gt square minus ut. Now, what is the height of the balloon from the ground just it releases the stone? Therefore, the height of the balloon from the ground when it releases the stone. How much? H is equals to half gt square minus ut. Half gt square minus ut. Same thing you will get. Okay. Are you getting? So this is the height of the balloon when just it releases the stone. Right. So let us see formula number 2 or note number 2. Right. The height of the balloon, the height of the balloon from the ground, when the stone hits, when the stone hits the ground, height of the balloon from the ground, when the stone hits the ground. Have a look. The balloon is projected the stone in a vertically upward direction, and the stone is moved like this, and hits the ground. So the balloon is moving with velocity u, and the stone is also moving like this. Okay. So balloon is moving like this, and the stone is moving like this. So when the stone is hits the ground, again height is increases. Again height of the balloon is increases. So let us consider from the ground h dash is the height of the balloon. Okay. And its height is given by half gt square when the stone is hits the ground. When the stone is hits the ground, the height of the balloon from the ground. What is that? H dash is equals to half gt square. So from this formula you can find the height of the balloon from the ground when the stone hits the ground. Okay. Right. Note number 3. So what is note number 3? Have a look. If the balloon is moves in a upward direction with a acceleration capital A, with the acceleration capital A, and a stone is freely fall, and the stone is freely falling towards the ground, freely falling towards the ground at any time t, time interval t, at any time interval t, the distance between the distance the distance between balloon and the stone is given by s is equals to half g plus a into t square, half g plus a into t square. So this is the displacement between the balloon and the stone when this balloon is moving with the acceleration a in a vertically upward direction. What is the formula? S is equals to half g plus a into t square. Are you getting? So just remember the formulas. You can do the problems like this only. Okay. Right. So pause the video and write the formulas. Are you understood the concept? Right. So 3, 2, 1, go. Right. So and just to bring the two example problems on the concept of balloon and the stone. Okay. So have a look. What is the first question they are given? A balloon starts from rest from the ground. I'm just going to draw the diagram by using the given question. Okay. So what they are saying, a balloon starts from the ground with a rest. That means initial velocity of the balloon is equals to how much? 0. And moves with a uniform acceleration g by 8. So this balloon starts from the ground with a rest and it is start moving in a upward direction with the acceleration. So acceleration of the balloon is how much? They are given a is equals to g by 8. So this is the uniform acceleration of the balloon. When it reaches a height h, let us consider the height of this balloon from the ground is a h. Okay, so now it is at a height h and it has a acceleration a is equals to g by 8. So after it reaches to the height h, what happened? A ball is dropped from it. A ball is dropped from it. As we know, whenever the ball is dropped from the balloon, so how it moves? It moves like this. Okay, already we are discussing now. With some initial velocity, the ball is moves like this and it hits the ground. Okay, so what we have to find the time taken by the ball to reach the ground. What we have to find? We have to find time taken by the ball to reach the ground. Are you getting? Right. So what they are given? Just they are given height of the balloon from the ground and the acceleration of that balloon. How much? A is equals to g by 8. And going to find the final velocity of this balloon. In a question itself they are given. What they are given? A balloon starts from rest from the ground. A balloon starts from rest from the ground means its initial velocity is 0. So displacement of the balloon is given. How much? S is equal to h. Acceleration of the balloon given. How much? A is equals to g by 8. Right. So in case of balloon, I'm just writing the equations for balloon. In case of balloon. Okay. So what is the displacement of the balloon? S is equals to h and its initial velocity 0 and the acceleration of the balloon is equals to how much? G by 8 and the final velocity of the object at a height h, let us say v. At a maximum height, the final velocity of the balloon is how much? Let us say v. Now this final velocity is becomes initial velocity for ball. Initial velocity for ball. U is equals to how much? V. Are you getting? Now the ball is moving towards the ground with this initial velocity. Then we can find the time easily. Okay. So we know the height formula. What is that? H is equals to half gt square minus ut. So from that we can consider that equation as what? Quadratic equation. And if you find the roots, then you will get the time. Right. So we have to find the final velocity of the balloon. Are you understood the concept? Right, very good. So I'm taking the equation of motion, that is v square minus u square is equals to 2as. So what is the final velocity of the balloon? V square we have to find minus initial velocity 0, which is equals to 2 into acceleration due to gravity of balloon is how much? G by 8 into displacement h. So 2 ones are 2 fours are. So we got v square is equals to g h by 4. If square went to that side, it becomes under root g h by 4. If 4 comes from root, it becomes root g h by 2. So this is what final velocity of the balloon. This is what final velocity of balloon. Now this is what? This is initial velocity for what? Ball. Initial velocity for ball. Right. Comes to the ball. In case of ball, what is the initial velocity of the ball? U is equals to under root gh by 2. This is what? Initial velocity of the ball. Okay. So what is the displacement or what is the height of the ball? Already I told you in a tower case. So what I told you, let us consider this is x and this is x. If this is positive x, then it becomes negative x. So plus x minus x get cancelled out and the ball is moved towards the ground. Then this height becomes what? Minus h. So displacement is equals to how much? Minus h. And as we know, the equation for displacement, what is that? H is equals to half gt square minus ut. This is what, ma? So this is the equation of height h for the ball. For the ball, not for the balloon. This is for ball. So height h is equals to half into gt square minus u. What is the value of u? Under root gh by 2. Okay. Now I'm going to write this equation is in the form of quadratic equation. So what is that? So half gt square minus root gh by 2 minus h is equals to 0. At the place of a, we have 1 by 2 g. At the place of b, here we have t now. Here also t. Okay, sorry, very sorry. Here we have t. Right. What is the value of b? b is equals to minus of under root gh by 2. And what is c? c is equals to minus h. Now how to find the roots? t is equals to minus b plus or minus under root of b square minus 4ac divided by 2a. So t is equals to minus b. That means what? Minus into minus plus. What is the value of b? Under root gh by 2 plus or minus under root of b square. What is the value of b? Minus of root gh by 2. If it is in a square, minus becomes plus and the square root get cancelled out. In the square, the 2 becomes 4. I'm just writing directly ma. So gh by 4 minus 4 into a. What is a? A is equals to half g 1 by 2 into g. So c. What is the value of c? Minus h divided by 2 into what is the value of a? 1 by 2 g. Are you getting any doubts? Right. So here 2 ones are 2 twos are 4 minus into minus plus 2gh. Okay. Right. So we will get our t is equals to how much? Under root of gh by 2 plus or minus under root of gh by 4 gh by 4 minus into minus plus 2gh plus 2gh divided by 2 to get cancelled out and we will get g. So in a denominator we have what? G. Okay, here g is there. Okay, gh by 2 plus or minus under root of gh by 4 plus 2gh. 4 2s are 8gh, 8gh plus gh 9gh, 9gh by 4. So we got what? So t is equals to gh by 2 root gh by 2 plus or minus under root 4 2s are 8, 8 plus gh 9gh divided by, this is 9 ma, not a g, 9gh divided by 4 divided by g. Okay, so t is equals to under root of gh by 2 plus or minus root over 9 means 3 under root gh divided by root over 4 means 2 divided by g. So it becomes t is equals to under root gh plus 3 root gh by 2g and down. It is also becomes t is equals to under root gh minus 3 root gh divided by 2g. So I'm just divide this term into plus 1 and a minus 1. Okay, so t is equals to 3 root gh plus root gh 4 root gh divided by 2g. So here t is equals to minus root gh, it becomes minus root gh by 2g. So negative time does not exist. Negative time does not exist. Just take 2 ones are 2 twos are. So we got t is equals to 2 into root gh by g. So this denominator g can be written as root g into root g. So here one root g is there. This root g and this root g get cancelled out and finally we get t is equals to under root of h by g. T is equals to under root of h by g. So this is the time taken by the ball to reach the ground. Are you getting? Right. So pause the video and write the solution. Pause the video and write the solution. I'm going to rough this part. Okay. So 3, 2, 1, go. Right. So let us see the second solution. Okay. Second question. Have a look what they are given. A balloon ascending at a constant acceleration 2 meter per second square. When it is at a height of 100 meters from the ground, a food packet is dropped from the balloon. Okay, is it clear? Let's draw the diagram. Okay, right, from the ground, let us consider this is a ground. Okay, Right? From this ground, the balloon is moving in a upward direction. Okay, what is the acceleration of the balloon? They are given a is equals to how much? 2 meter per second square. And this balloon is at a height how much? 100 meters from the ground. 100 meters from the ground. A food packet is dropped from the balloon. A food packet is dropped from the balloon. As we know, when the food packet is dropped from the balloon, how it is moves? So from this height h, the food packet is moves like this. Okay. Are you getting ma? Right. The food packet is moved like this towards the ground and it hits the ground. So what they are asking, after how much of time and with what velocity does it hit the ground? We have to find time taken by the food packet to reach the ground as well as with how much of velocity the food packet is hits the ground. So these two things we have to find. So before going to find the what we have to find, we have to find what is the initial velocity of this food packet. So how we will get the initial velocity of this food packet? So the final velocity of the balloon becomes initial velocity for food packet. So the initial velocity of the balloon, I'm just finding the final velocity of balloon. So this is in case of balloon. Okay. So balloon. What is its initial velocity? 0. What is its final velocity? We have to find. Okay. So what is its displacement? S is equals to 100 meters. Okay. So what is its acceleration? 2 meter per second square. So to find the final velocity, we have the equation. What is that? V square minus U square is equals to 2as. Are you getting any doubts? Right. Very good. So initial velocity 0. So V square is equals to 2 into what is the acceleration due to gravity? 2. And what is the displacement? 100 meters. So V square is equals to 2 to the 4. 4 into 100? 400. And we got V is equals to how much? Root 400. And V is equals to 20 meter per second. And now this is what? Final velocity of the balloon is equals to how much? 20 meter per second. This is becomes what? Initial velocity for food packet. What is that? 20 meter per second. Now I am going to find the information of food packet. Okay, food packet. Right. So what is the initial velocity of the food packet? UF, food packet. Initial velocity is equals to 20 meter per second. Are you getting? Right. Just taking the time to reach this food packet to the ground is t is equals to t only. So what we have to find? We have to find its final velocity. Okay. So in case of stone or in case of food packet, whatever it is, have a look. Here the displacement is plus x and from here to here displacement is minus x. So plus x minus x get cancelled out. So what is the equation for remaining height? H is equals to half gt square minus ut. Half gt square minus ut. Are you getting any doubt? Right. So what is h? H is equals to 100. H is equals to how much? H is equals to 100 meters. Okay, from here to here. Okay, half. They are taking g is equals to how much? 10 meter per second square. So 10 into t square minus u. What is u? 20. Time we have to find. Okay, 2 ones are 2 5s are. We got 5t square minus 20t. If 100 went to that side, it becomes minus 100 is equals to 0. I am taking 5 common. 5 ones are 5. 5 4s are 20. 5 20s are 100. So finally we got 1 into t square minus 40 minus 20 is equals to 0. Equation is in the form of ax square plus bx plus c is equals to 0. Okay. So we can write out a is equals to 1. I'm just finding the values of a, b, c. So b is equals to minus 4 and c is equals to minus 20. Then time values t is equals to minus b. I'm just writing directly ma. Okay. So minus b plus or minus under root of b square minus 4 into a into c. C value is how much? Minus 20. Minus into minus plus divided by 2 into a. 2a. Okay na? So 2 into 1, 2. Then t is equals to, it becomes, so 4 plus or minus under root of, have a look, 24 is 80. 80 plus 16, 96 divided by 2. This is what? 96. Then t is equals to I'm just writing this equation as 4 by 2 plus or minus under root of 96 divided by 4. Under root of 96. 2 becomes, if 2 went to root, it becomes 4. Are you getting? 4 by 2 plus or minus under root 96 by 4. Okay. So we can write a 2 ones are 2 twos are. So 4 ones are 4, 4 twos are 8, and 4 fours are 16. And finally we got t is equals to 2 plus root 24. 3 plus root 24. If it is what? This is for plus term. And if you write for minus term, you will get 2 minus root over 24. So the value of root over 24 is becomes a nearly equals to 4 point something 6, 4.6 you will get. 2 minus 4.6, you will get how much? Minus 2.6. So minus 2.6, negative time does not exist. So it is not exist. And finally we got the time equation t is equals to how much? 2 plus root over 24 seconds. So, the time taken by the food packet to reach the ground, how much? T is equals to 2 plus under root of 24 seconds. Root over 24 value is 4.67 something. Okay. So 4.6 plus 2, 6.67 you will get like that. Okay. Okay. So time we find the, and we have to find the final velocity. So for final velocity, we have the equation. So what is that? V square minus u square is equals to 2as. V square we have to find minus u square. What is the value of u initial velocity? 20 meter per second. So 20 square. This is equals to 2 into a is equals to acceleration due to gravity 10 they are given into displacement s is equals to how much? 100 meters. Are you getting? So v square minus 20 whole square, it becomes 400. This is equals to 100 into 10, 1000 into 2, 2000. Okay. So then v square is equals to, if minus 400 went to that side, it becomes 2400. So v is equals to under root of 2400. So finally you will get v nearly equals to 49 meter per second. So with this much of speed, the food packet hits the ground. What is the final velocity? 49 meter per second. What is the time taken by this food packet to reach the ground? 2 plus under root of 24 seconds. Are you getting? Right. So pause the video and write the solutions. 3, 2, 1, go. Right. So let us discuss our last application based on the same concept. Okay. So this is our last application of this session. Application. Application or application. Application. Right. So at this time they are taken out 3 towers. How many towers? 3 towers. Let us say this is the first tower, and this is the second tower, and this is a third tower. So these 3 towers having the same height h, same height h from the ground. H, h, h. Okay. So at the same height from the ground. Are you getting? Right. So let us say this is a first tower, second tower, and a third tower. Okay. So from this tower, first tower, they are projected an object in a vertically upward direction with a velocity u, with initial velocity u. Now how does this stone or object moves? It moves like this, right? La 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 la. Okay. Any problem? Okay, no problem. So at this time, they are projected an object or a stone in a downward direction with an initial velocity u. That means they are thrown an object with some initial velocity. At this time, they are just taken initial velocity of the object is 0. Okay. So that means what? It is a freely falling body. It is what? Freely falling body. Right. So what they are asking, first one, find out initial velocity of the object. Find the initial velocity of the object. So this is a first question. Are you getting ma? Okay, very good. Have a look. In a first case, I am taking the total time taken by the object to reach the ground is t1. In a second case, the total time taken by this object or stone to reach the ground t2. Okay. So in a third case, I am taking the total time taken by the object to reach the ground is T3. Okay. So have a look in a first diagram. In a first diagram, here we are thrown an object in vertically upward direction, and this object is moves like this, and it reaches to the same point of projection. This is what same point of projection. Have a look. The time taken by the object to reach maximum height from the point of projection is called what? Time of ascent. Okay. So the total time taken by the object to reach the point of projection from certain height or from maximum height is called what? Time of descent. That means the total time taken by this object to reach a point of projection, is called what? Time of flight. Okay. Point of projection to maximum height to point of projection, time of ascent, time of descent. So total time is what? Time of flight. Are you getting? Right. Now the object is at a point of projection, and with how much of velocity we are projected this object? With the initial velocity u. So again this object is reached to the point of projection with the same velocity u. Now at this point, what is the final velocity of the stone? U. Are you getting? So now the stone is at this point and it is moving towards the ground with velocity u. Okay. Have a look. Observe these two diagrams, first diagram and second diagram. In these two diagrams, at this point, at this level, at the same height of the tower, the initial velocities of the two objects is how much? U only. Now the total time taken by the two objects to reach the ground is also same. So let us say this is T1 and this is T2. T1 is equals to T2 from this point, from this height. But one thing is clear that compare with this object travels more distance. This object travels more distance. That means it takes more time to reach this point. To reach this point, how much of time it taken? Time of flight. In writing the time equation as T1 minus Tf is equals to T2. T1 minus Tf is equals to T2. Can I write like this? Have a look. The time taken by these two objects to reach this much of height is same. That means T1 is equals to T2. But T1 is more than T2. How much it is more? Time of flight. Just to remove Tf from T1, then it gives what? Time T2. Are you getting? Right. So T1 is equals to T2 plus Tf. T1 is equals to T2 plus Tf. So if I bring this T2 to this side, it becomes T1 minus T2 is equals to Tf. What is Tf? Time of flight is equals to how much? 2u by g. Just substitute here. So T1 minus T2 is equals to 2u by g. So from this we can find the initial velocity u is equals to, if 2 comes to this side, it becomes 1 by 2 into T1 minus T2. If g went to this side, it becomes numerator. So this is the initial velocity of the object with which we are projected in these two cases. Are you getting? Any doubt? Right, very good. So let us see the second one. Find the height of the tower. Find height of the tower. Right, we have to find what? Height of the tower. In a first case, or in a first diagram, what we have? Initial velocity of the object, u is equals to how much? We got u is equals to half T1 minus T2 into g. Okay. So whenever the object is moving away from the tower or ground, acceleration due to gravity is equals to how much? Minus g. Okay. So the time taken by this object to reach the ground, how much? T is equals to T1. What we have to find? Displacement. That is height of the tower is equals to how much? Okay. Have a look. The object is moving like this. Okay. Moving like this. This is a plus x and this is a minus x because it is moving towards the ground. Plus x minus x get cancelled out. Remaining height is equals to how much? Minus h, because the object is moving towards the ground. The object is moving towards the ground. So here s is equals to minus h. So finally, as we know that height for the tower h is equals to half gt square minus ut. Right. Let us we substitute all these values in a height equation. So we got h is equals to half g. T means what? T1 square minus u. What is the value of u? Half T1 minus T2 into G into T is equals to how much? Again T1. So H is equals to half G T1 square minus half T1 G into T1. T1 into T1 T square. G into 1 by 2 1 by 2 G T1 square minus into minus plus half G T1 into T2. Are you getting? I'm just expanded this term. Okay, I multiplied GT1 with this term. The minus into minus it becomes plus half GT1 T2. I'm just expanded. So this term get cancelled out, and we got H is equals to half G T1 into T2. So this is what? This is the height of the given tower. Height of the given tower. Now I want to find the time T3. Find the T3 in case of last tower. In case of last tower. Right. In case of last tower, what is its initial velocity? U is equals to 0. What is its displacement? S is equals to H. Already we got the H value. How much? This is equals to 1 by 2 G into T1 into T2. Okay. So what is time? T is equals to T3. This is what we have to find. Okay. I'm using the second equation of motion. What is that? S is equals to ut plus half at square. S is equals to ut plus half at square. So I'm substituting these values in this equation. S is equals to H is equals to how much? Half G T1 into T2. Initial velocity of the object 0. 0 into something 0. Half acceleration due to gravity. This object is moving towards the ground. Then A is equals to how much? Plus G into T square. What is the time? T3 square. So 1 by 2 get cancelled out. G get cancelled out, and we got T1 T2 is equals to T3 square. From this we can write T3 is equals to under root of T1 T2 seconds. So this is the time taken by the body to reach the ground in case of third tower. How much? Under root T1 T2. Okay. Pause the video and write the concept. 3, 2, 1, go. Right. So this is the end of the today's session. I hope that you are enjoyed this session. Okay. So we have discussed a lot of things. So what are those? So we have to find the height of the tower H when the object is projected from it. Okay. And we have discussed about a balloon and the stone formulas and the problems on that concept. And this is our last concept. Okay. So what is the initial velocity, and what is the time, and what is the height of the tower when the object is projected different from different towers. Okay. So this is the end of the today's session. Keep watching. This is Rakesh signing off. Jai Hind.